Solving systems of linear inequalities. So the first thing that we're going to discuss in this video is identifying if a coordinate is a solution to a system of linear inequalities. So before we talked about systems of linear equations, remember inequality is the only difference between an inequality and an equation. When you look at it, is there isn't an equal sign. There is a greater than sign, there's a less than sign, or a greater than or equal to, or a less than or equal to. So we're going to be working with these. So we need to tell whether the ordered pair is a solution of the given system. So if we look at the little letter A problem, we have the point 2, 1. So the x value is 2, the y value is 1. And I need to see if when I plug those numbers in for the corresponding x and the y, see if it is a solution. So let's take a look at the first equation. So plug 1 in for y. So 1, is that less than a negative 2 plus 4? Okay, let's evaluate the right side here. So negative 2 plus 4 will give me a 2. And is 1 less than 2? Yep. So the first one works. So it has to work for both of them in order for it to be a solution. Let's try the second one. So plugging in 1 in for y. So we have 1. Is that less than or equal to a 2 plus 1? Well, 2 plus 1, that'll give me 3. And 1 is less than 3, so that one also works out. Letter A is a solution. So it's got to work for both of them. If it doesn't work for one of them, or it doesn't work for both of them, it's not a solution. Let's take a look at letter B, see if this one works. Plugging in 2 in for x and 0 in for y. So is 0, when I plug it in for the first one, is that greater than or equal to 2 times 2? Well, 2 times 2 will give me 4. So is 0 greater than or equal to 4? 0 is less than 4, isn't it? So that one actually doesn't work out. Now, when you come across one that doesn't work, you don't really need to do the other one. I already know that this is not a solution. So if it doesn't work for one of them, you know you're done. So going on to a few more problems. Again, telling whether the ordered pair is a solution of the given system. So for 1a, we have to plug in 0 in for x and 1 in for y to see if they're going to work out. So plugging in for the first one, I want to see if 1 is less than negative 3 times 0 plus 2. Okay, evaluating this side. Remember your order of operations. Multiply first. Negative 3 times 0 just is 0. So that pretty much just cancels out. 1 is less than 2. So the first one works out. The second inequality, I might mistakenly call them equations, so bear with me, they're inequalities. 1, is that greater than or equal to 0 minus 1? Okay, so 0 minus 1 will give me a negative 1. And is 1 greater than or equal to negative 1? Well, it's greater, so that one also works. So 1a right here, that is a solution. 1b, pretty easy one to use. I need to plug in 0 in for x and 0 in for y. So is 0 greater than a negative 0 plus 1? Well, a negative 0 is just a 0. So is 0 greater than 1? 1's greater than 0, isn't it? So that one right away doesn't work. So you can plug it in for the other one, but whether or not it works or not, I already know that it is not a solution. So it has to work for both of them. So you want to be really picky about these. Not a solution. So if you think back to when we talked about linear inequalities and we graphed them, remember we had, let's say we had a Cartesian plane here, xy axes. And we graphed a line. Now that line could either be dotted or dashed. I'm just going to make a dotted line just for an example. You make either a solid line or a dashed line. And we either shaded above or below that line, just to give you a little refresher on how linear inequalities worked. And if you remember back, I made a little table that kind of organized whether we made a solid line or a dashed line. And shaded above or below. So there's 4 different combinations that you're going to get, and each combination has its own symbol. So we have less than, and we have greater than, and we have less than or equal to, or greater than or equal to. All right. Now this table might look a little different, but it's going to work the same way. So if it's less than or equal to, that means I'm going to shade below. So on the right side, we're going to talk about shading. And if it's greater than or equal to, we're going to shade above. Now, if it has that line underneath, like the less than or equal to, greater than or equal to, we're going to make a solid line. And if it doesn't have that line, it's just strictly less than or strictly greater, we're going to make a dashed line. So which line do I make? And then where do I shade? So I can review this because when we talk about systems of linear inequalities, remember a system is just basically 2 equations, or in this case, 2 linear inequalities. Now, if you look at these examples, example 1a and example 1b, we're actually going to graph 2 linear inequalities together. And you'll notice that they have one of the lines here, and they shaded below. And they graphed another line, which was a dotted line, and then they shaded here. So remember those previous problems we talked about, is a coordinate a solution for the system, where this overlapping region right here, every single point in this area, and not touching that dotted line, but you can touch that solid line right here, all of those points are a solution and will work for both of those inequalities. The same for 1b. You notice how there's this overlapping region? And they kind of identify points. 2, 0 is not a solution because if you look at it, it's not in the double shaded region. And right here they have the 2 point, or the 2, 1 point, which I kind of colored over with, but it was right there. Since it was in the shaded region, it was a solution. So this is what our, when we graph our systems of inequalities, is going to look like. So let's just take a look at one example of a linear inequality. So basically, you're just going to graph both of them. So we have y is greater than x minus 3, and y is greater than or equal to negative x plus 6. So if you remember our little tricks that we did, the y-intercept and the slope, if you look at the first one, I have a y-intercept of negative 3. So we'll plot a point there. And I believe on these problems, they're going to say identify, before I go on too far, a point that is a solution. And one that is not. So just writing little directions up there. So again, continuing graphing that, I have y-intercept of negative 3, a slope of 1, so I got to go up 1 over 1. And we have a greater than, so I'm going to make a dotted line right there. Since it's greater than, I'm going to shade above. I'm going to shade in blue for that. So it doesn't matter how you shade, you can just kind of scribble however you want. Okay, so every point up there would work for the first equation. And looking at this, or not the equation, inequality, for the second inequality, I got y is greater than or equal to negative x plus 6. So we got a y-intercept of 6, a slope of negative 1, so we go down 1 over 1. I have to make a solid line for that one. So something like that. There's the line. And I shade above or below. I got to shade above. So I'll do that in red. So if you look at this one, where is the region that is shaded twice? And so you look at this, and you might say that, oh, it's this region right here. So I'll color that in green. So you can get close to that one line. You can get close to the dotted line, but make sure not to color it in because those technically are not solutions. So now you have to identify what is a point that is a solution and one that is not. So basically, any point in here. So I'm just going to pick one right there. That point is 3, 5. So that one is a solution. How about one that is not a solution? So you could actually pick anything outside the double shade region. You could pick some in that blue shade region, or some in this red shaded region, or one that is not even shaded at all. So these regions kind of indicate, like the red, it would work for the second inequality, but not the first. The blue would work for the first one, but not the second one. And then points in the one that isn't shaded at all, it wouldn't. Those points wouldn't work for either one of them. So whatever point you want to use, 0, 0, or whatever one you want to use, that would be one that is not a solution. So let's take a look at another problem, just like the one we just did. So we have to graph the system of inequalities, identify a point that is a solution and one that is not. So let's graph both of these. We have y is less than x. Now you might remember the from the transformations, the graph of y equals x. You should always remember that one. Is the line that is diagonally through 0, 0. So something like that. I made a dotted line because it's strictly less than. And then should I shade above or below? Well, since it's less than, I'm going to shade below. So I'm shading this one in red. And have fun with the shading. The next inequality, I have y is greater than negative 2x plus 1. So I have a y-intercept of 1 right there. I have a slope of negative 2, so I have to go down 2 and over 1 for a second point. And I have to make a dotted line again, since it is strictly greater than. Something like this. And I have to shade above that line. So here we go. So now identifying a point that is a solution and one that is not. Looking at this one, what is my double shaded region? And that is right here. I'll color it green. Now remember, you want to get close to that line, but you don't want to actually touch it, because technically points on that line are not solutions. Now, one point that is a solution. So again, anything that is in that green region right here, let's pick one right here. That is the point 6, 2. That is one that would work. How about one that is not a solution? Again, anything in the blue or the red or the one that's not shaded at all. Now you actually could be tricky and say, oh, well, a point on the dotted lines would not be a solution as well. So if you want to be brave with that. Otherwise, just pick a random point, like right here, negative 4, 5. That is one that is not a solution. Just to be a little fancy, how about I choose a point that is right on that line, 2, 2. That is also one that is not a solution. Because if you plug 2, 2 into the first one, is 2 less than 2? And it's equal to. So that's why there's a lot of difference between that less than or equal to and strictly less than. So here we're going to graph systems that are parallel. So these lines will be parallel. Sometimes you'll have solutions, sometimes you actually won't. So we'll take a look at a few of these. So again, just graph the things. We have y is less than 2x minus 3, so we have a y-intercept of negative 3. I got to go up 2 over 1 for another point. We make a dotted line. I have to shade below. So I'll do that in red. Okay, the second one, I have y is greater than 2x plus 2. So I have a y-intercept of 2. I got to go up 2 over 1. Again, make a dotted line. Okay, now do I shade above that or below that? So since it's greater, I have to shade above. So again, identifying um, a point that is a solution and one that is not a solution. Okay, now if you look at this one, is there any area that is double shaded? Okay, so you might say, well, no, there really isn't anything that's double shaded. So there actually isn't any points that are going to work for both of them. So there are no points that are solutions. So knowing that there would be some points that work for one, but they won't work for the other one. How about points that are not a solution? Well, you really have your pick of the litter here. You can pick any point because any point would not work for both of them. So how about we pick one of them right here? How about 5, 4? That one is not a solution. So the tricky part about these is sometimes you might not even have a solution. Take a peek at this one. We have y is greater than x minus 3. So a y-intercept of negative 3. I got to go up 1 over 1 and then make a dotted line. And then it is greater than, so I have to shade above that line. So here we go. There's my shading. The next one, I have y is less than or equal to x plus 1. So I have a y-intercept of 1. I got to go up 1 over 1. And I have to make a solid line. And you notice that all these are parallel to each other. It is less than or equal to, so I have to shade below that solid line. And you might think to yourself, well, which is the double shaded region? And you might say that this one in the center, this little area right here, that's my double shaded. So this system has a solution, unlike the other one. And just pick a point in that green shaded region. How about -1, -2? That one will work. One that is not a solution. Anything outside that green on the top and bottom. How about, oh, one right here. How about 4, -4? Yeah, 4, -4. Or whatever one you want to use. All right, let's take a look at one more. So, again, graphing these. So the first inequality, I have a y-intercept of -2. So let's plot that guy down there. Slope of -3, so go down 3 over 1. And I have to make a solid line. And I have to shade below. So I'll do that one in red. Graphing the other line, or right here, inequality. So I have y-intercept of 4. I have slope of -3, so again go down 3 over 1. Make a solid line. So here we go. And I also have to shade below. So everything over here is also shaded. So you might notice that, oh, the double shade region is, well, basically this stuff right here. So if we talk about solutions and points that are not solutions, all the solutions are going to be in this area right here. So whatever you want to use, how about we choose this one right here? So the point -5, -3 would be 1. And one that is not a solution. So anything, and you can actually use things that are in the sliver here because it'll work for one of them and not for both, or this region here. So how about the point 6, 1? That'll be a point that doesn't work for both.